built on object storage. And next, I will introduce the latest feature of AutoMQ table topic and show how to integrate the streaming and analytics workload with Iceberg table format. And third, the last part, today's topic of the meetup is data and AI, right? So I will share some insights about the data streaming and the AI agents, and also the data-driven architecture and AI agents. Yeah. So let's move to the first part. So what is AutoMQ? Typically, AutoMQ is a cloud-native alternative to Apache Kafka. It's built on object storage like AWS S3, and also it's an open source project. You can find it on GitHub and welcome to start and clone it. And currently, we have almost 6,000 stargazers worldwide and over 40 co-contributors from many companies like AutoMQ, Grab, Zhihu, Workloads, Jingdong, and so on. So if you want to join the community or you want to become a contributor of AutoMQ, welcome to join us here. So far, we know that AutoMQ is built on object storage, but to be honest, object storage is not very suitable for building streaming storage. And actually, we have faced many challenges for building AutoMQ on S3. I mean, there are some good things and bad things. For example, S3 is highly scalable and maybe it's the largest storage in the cloud, so it's ideal for stream storage. For Apache Kafka, and many customers run Apache Kafka at scale and will handle large volumes of data per second. Yeah, maybe from several hundreds of MB stream storage. And S3 is the most cost-effective storage in the cloud. And like Apache Kafka is a data-intensive system, so cost efficiency is very crucial. Yeah. But S3 also has some limitation for being stream storage. Like S3 is very high latency. So each API call to S3 has hundreds of milliseconds of latency. But in the real world, there are many real-world scenarios that need low latency, like dynamic pricing, real-time recommendations, and fraud detection. Yeah, all these scenarios require extremely low latency. Yeah. And also, object storage is not optimized for writing. It's not designed for high LPS. But for Apache Kafka, it's unpartitioned systems, right? Imagine that you have 1,000 active partitions, and if you write data to all the partitions directly to S3, even you write data once per 100 milliseconds, it will cost you about 10,000 pull requests to S3. So trust me, it's a huge cost. Yeah. So to reap the benefits of object storage and overcome the disadvantages of object storage, we have developed a streaming storage library on S3. Yeah, it's called S3 Stream. Yeah, S3 Stream consists of a data storage layer and a word storage layer. So there is no doubt that the object storage will be the best option for data storage, given its high throughput and low latency, right? But as I mentioned before, object storage is not optimized for writing, right? So we have introduced a word storage. Basically, this is a read-ahead log, and it's optimized for writing. Yeah. So at a given time window, all the partitions from different partitions will be aggregated into a single object or single block and then committed to the word storage. Yeah, so it's very cost effective by design. The word storage doesn't need to need extensive LPS or big space, so it's very cost effective. And so the data from the producer is written to the word storage persistently and then uploaded to the object storage in nearly real time. So the consumer will access the data via S3, but of course, there is a read cache for acceleration. So for the tenant read consumers, don't need to access the data from S3 directly. Yeah. So another point is that all storage can have many different implementations. That means a very flexible architecture. For example, all the major cloud providers offer EBS, right? So you can just use EBS as a wall storage. But please note that EBS is a single AZ product. So if you want to AutoMQ to tolerate the complete AZ failures, so you must consider other options. For example, like some cloud providers like Azure, GCP, and Alibaba Cloud offer regional EBS, so which makes it be your best choice to use regional EBS as a wall storage. And also, if your scenario can be latency relaxed, you can just use S3 as a wall storage. That means you can use object storage for both the wall storage and the data storage, making the architecture very simple and clean. Yeah. So also the classical NFS protocol is also supported by AutoMQ, which means you can use AWS file storage services as a wall storage, like AWS EFS or AWS FSx. Yeah. So this is a S3 stream. So now we have S3 stream and we can transform the shared NAS architecture of Apache Kafka to a shared storage architecture. And we have found a very small aspect to replace the Intel storage layer of Apache Kafka with S3 stream. And so now, so this architecture has 3 layers. The last layer is about the cloud storage. So of course, we should choose the object storage as a data storage. And if you choose EBS as a wall storage, and each broker only need 10 GB EBS volume. So the cost of is negligible. I mean, if you chose a GP3 EBS, a 10 GB GP3 EBS, the monthly cost is less than $1. Yeah, it's very cheap. Yeah. And also the S3 stream doesn't need replication data anymore. I mean, both the EBS and S3 provide high durability. For S3, and it offers over 11 lines durability. So iteration coding technology. Yeah, so we don't need to replicate the data anymore. So after we replaced the replication-based storage layer of Apache Kafka, we have transformed the architecture into a stateless architecture. And so once it becomes stateless, it's easy for us to set up an AutoMQ cluster and just like deploy a microservice. Yeah, it's very easy. And even you can employ support instances to deploy AutoMQ cluster. Yeah. So after that, we can automate everything to achieve an elastic architecture. So we have 2 automatic controllers. The first one is the auto scaling controller, and which watches the load of the cluster and make decisions to scale in or scale out the cluster based on the workload. Sorry. Okay, the next controller is about the auto balancing controller, which can minimize the hotspot issues by dynamically reassigning partitions among the Intel cluster. Yeah. So this is the architecture of AutoMQ. And there are 3 key advantages of AutoMQ. The first part is about the cost. And AutoMQ's shared data architecture can achieve a 10-fold cost reduction for both the storage and the computation. Yeah. For the storage, AutoMQ has replaced the 3 replication EBS storage layer with single replica object storage, so which is more than 20x cheaper. For the compute, AutoMQ's elastic architecture can prevent over provisioning and can auto scale based on your workload. So even you can use support instance which So makes it very easy to achieve reduce 90% cost for the compute. So, and what's more, the AutoMQ's shared storage architecture can greatly enhances the operational efficiency. So if you run Apache Kafka at scale, there are two operational tasks, high frequent operational tasks. One is partition reassignment. For AutoMQ, reassigning partitions no longer involves any data replication, so it can be finished maybe less than 3 seconds. But for Apache Kafka, you need to replicate all the data of the partition, and from the broker A to another broker. After that, you can finish the partition reassignment, which it can take up to several hours. Yeah. So when it comes to cluster scaling, for AutoMQ, it's very easy for us to set up a new broker, and the auto balancer controller will automatically reassign partitions among the Intel cluster. So less than 1 minute, the traffic will be balanced again. But for Apache Kafka, it's very difficult. It may take up to days to scale up a new broker. Yeah. Another point is that AutoMQ, we have replaced the storage layer of Apache Kafka while keeping all the code from the computation layer. So which means AutoMQ is 100% compatible with Apache Kafka. We have passed all the end-to-end tests and support all the KIP features like idempotent producer, compact topic, transactional messages. All the features are supported by AutoMQ. So what's more, it's easy for us to synchronize code from the Kafka upstream in the future. So obviously, it's a big challenge for other vendors. Yeah. Okay, let's move to the next part, and I want to introduce the latest feature of AutoMQ, table topic, and to show how to unify streaming and analytics with Iceberg. Before that, I want to share an innovation about the shared data architecture. And we can observe a trend that more and more data-intensive systems are built on object storage. But even all the data are stored on object storage, there is no easy way to share the data among different systems. So the ETL jobs, data format conversion are needed here. So, we think the transition from shared data architecture to from the shared storage architecture to shared data architecture will be the next critical evolution of modern data technology. So the modern table format like Apache Iceberg gave us an opportunity to unify the data format in the object storage. So in the imagined shared data architecture of AutoMQ, the data is generated in streaming manner first, and then appended to the stream storage. Now your Flink jobs, your Spark streaming jobs, and the Kafka consumers can mine the real-time value through the streaming APIs, right? So after the data loses its freshness, the table topic feature can convert the data to Iceberg format directly. So now the modern big data compute engine can access this data through a zero ETL approach. So that would be very simple and cost effective. Yeah. So this is why we want to introduce the feature table topic to integrate your stream data into the Iceberg. So then let's have an in-depth look at the table topic architecture. And there are three important parts of table topic. The first one is schema and catalog management. So AutoMQ's table topic feature provides a built-in Kafka schema registry and also supports automatic schema evolution. And for the catalog service, we currently support AWS Glue and Table Bucket, or the Hive Metastore as a catalog, and also the REST catalog. And the core component of the table topic is the table coordinator. Each topic has a table coordinator and always run along with the partition 0, and which is responsible for centralize the coordination for iceberg snapshot submissions, can reduce commit frequency and avoid performance conflicts. And another important component is the table workers. The table workers is embedded in AutoMQ brokers, and we have for each topic in the broker will have a table worker which holds an iceberg writer to write the data to the iceberg format. And also the table worker will handle the data uploads by listening to the commit request events emitted by the table coordinator. And the table coordinator will send many RPC requests to table workers through inner Kafka topic. So now we both have the stream storage and the table storage in one AutoMQ kernel. Now we can ingest many data from data sources and store them on both streaming and the table storage. So the modern data technology like compute engine like Spark, Apache Flink, Presto, and Hive can access this data through a zero ETL approach. There are many benefits of AutoMQ table topic. The first one is that it's very easy to set up and no extra configurations, no Flink jobs, or no Kafka connect needed. And also, we both know that every database needs a bin log, right? So the log side of the table topic can serve as the bin log for the iceberg table, so which is the source of truth of the iceberg table. And the most outstanding benefit maybe is the zero ETL. The table topic can eliminate traditional ETL pipelines, can reduce cost and operational complexity significantly. The last one is about the auto scaling, and now we know AutoMQ is a auto scaling architecture, and the table topic is a built-in feature. So we can leverage the auto scaling and auto balancing controllers to seamlessly scale the table worker and with the data ingestion rates. The last one is about AutoMQ can seamlessly integrate with AWS S3 table. Now we can leverage many features of S3 tables like its high performance, its integrated catalog, and the table maintenance. So if you have S3 tables, you don't need to worry about any efforts for table maintenance like garbage collection, data compaction, or the snapshot management. So what's more, AutoMQ table topic can work well with AWS analytics products like Asana, EMR, Redshift, QuickSight, and so on. So next, I want to share a very simple example to show how get started with table topic on AWS. First, you should create an AutoMQ cluster with table topic feature enabled. So it's very easy, just one click to enable it. And then we can create a test table topic. And then we can prepare some clickstream data and maybe use the error reproducer and send some clickstream data to a table topic. And then we can just use simple as SQL to select the data from the table topic using AWS Asana. You will get a result in seconds. It's very easy to use. Okay, so let's move to the next part. And I want to share some insights about AI agents and the relationship between AI agents and data streaming and the data-driven architecture. Okay, for these 2 years, we can observe that more and more companies and developers are shifting their focus from the chatbots to AI agents, right? And I think it's a good thing that, which means the AI is really making a real impact across various industries, right? So actually for chatbots and agents have very different data requirements. Yeah, for conversational chatbots, it basically, chatbots and using the static model with static data and just to answer the questions, and they don't need to make any decisions, right? But for AI agents are systems that can take actions. So they need the real-time data to make the real-time actions. So the first insight about AI agents, and I think the real-time data is the fuel for the AI agents. Yeah. And the second insight is that, and I think the data-driven architecture maybe is the best development pattern for building real-time AI agents. So this is an architecture overview, and the data can be from many data sources, like your databases, your log systems, or your legacy systems. And once you collect the data into the AutoMQ cluster, you can use your streaming process engine like Apache Kafka to enrich, join, or filter your data. And then your real-time AI agent will act as a Kafka consumer to subscribe the data and to pull the data from AutoMQ cluster. And maybe you will need additional context, and you can use the MCP protocol to retrieve the additional contextual information from your databases, like graph databases, vector databases, or relational database. And now you have the data source and you have the additional context. You can fit them into your large language models for reasoning. Of course, you can use your predefined properties, and after you get the result from the models, and you can sync it to your target. If your target is an HTTP API or microservices, you can use MCP to call your systems. Or if it's a complex job, you need help from other AI agents, you can just emit a new event with data and context to AutoMQ, and your other agents will subscribe data. Yeah. So this architecture has some benefits. It's highly scalable. You can scale many AI agents to subscribe the same topic to speed up the data process, right? Also, it's very low latency, and it's loosely coupling, which means your AI agents don't need to depend on other agents directly. Yeah. So next, I want to share some imagined use cases for building real-time AI agents. The first one is about building an AI ops agent. And I want to share a story of our team. One day we have received an error log alert from our production environment. It shows in your production environment, maybe there is a resource leak problem. And to speed up the root cause finding, and we feed the error log and as well as the code snippet to DeepSeek for reasoning. And a few seconds later, the DeepSeek find all the potential paths to find the root cause, and it suggested there may be a concurrency issue. So it's very impressive. So from my perspective, I think using large language model to build an AI ops agent is definitely possible. So simply you just need to collect your logs from your production environment and send them to AutoMQ cluster, and you write your own AI ops agent to monitor the error log. Once you find something critical, you can use a DeepSeek for reasoning and send the result to your engineer and help them to find the root cause quickly. Yeah. Okay, our last case is about real-time recommendation agent. Imagine that you are developing an AI agent for your online shopping system, and you want to engage the customers to buy more and more your product, right? And so first you should have your click stream in your AutoMQ cluster, and you let Flink help you find the high quality sales leads. Like if some customers have scanned one kind of product for several times in a very short time window, but they don't buy it eventually. So maybe this is a very strong signal to show that they are interested in your product, but the product may be not good enough to meet their requirements. So for this needs, you can write your recommendation agent to subscribe the data and use the MCP protocol to retrieve the customer profile, along with the similarly high-rated products, and feed them to large language models for generating an paid offer. And once you have the paid offer, you can just send an email to your customers to engage them to buy it. Yeah. The last case is about live AI translation, and like you are joining an online meeting room, and there are multi-language speakers. One of the speakers is speaking English to say hello to other participants, and the live stream can send to the AutoMQ cluster. You can write your own translation agent to use the models for translation, and dispatch them to other participants, and other participants can see the local language subtitles. Yeah. So these are some use cases about how to use data-driven architecture and use data streaming to build real-time AI agents. Okay, that's all my presentation. And thanks. If you want to learn more about AutoMQ and you want to further discuss about the technique, you can scan the code using your Slack application to join your community. Yeah. Okay, that's all. Thank you for your time. Any question?
We can answer 2 questions for each session.
I have a question. Could you go back to the cost?
Cost, okay.
For the rate bars.
This one?
Yeah.
Yeah.
For the rate bars, what are the assumptions and considerations that we use to calculate the cost for this?
Sorry?
So for the because we did a cost comparison of the storage and compute.
Yeah, we have a benchmark report on our website. You can check it out. The real billing conversion.
Okay.
Any questions? One more question? Yeah.
Comparing AutoMQ with Solid
or
or any traditional MQTT broker. So, or let's say, what's your opinion on next generation stream message broker comparing with all the traditional brokers? What's your differentiator?
Okay, it's a complex question, but actually Kafka and MQTT are 2 very different solutions, and MQTT is served for maybe IoT scenarios, but Kafka is for big data. It will handle large volumes of data, like your click streams, your logs, your tracing data. So basically, there are 2 different solutions for different scenarios. Yeah.
Do you think EMQ will be your competitor?
No, EMQ is a partner. Actually, we have some collaboration. We have some joint customers. They both use EMQ and AutoMQ. Yeah. Thanks.
Okay, thanks, Bill.
Thanks, guys.
Okay, thanks, Xinyu, for the first session, and our second session is so can you bring up the training slides?
Okay.
Okay, our second session is from meetup TiDB and Demai. Let's welcome him.
Thank you. Do you think so? Controller or? Oh, no, doesn't work. Okay, sure. Okay. Just want to make sure I have a timer here. So as we are talking about cloud, everything is about resource.
So time is a resource that we cannot afford. So I'm always have a timer here. Anyway, yeah, thank you guys for coming here. My name is Demai, and today I'm here to share TiDB, the cloud native database, and particularly for today's technical talk, I'm talking about the Web3 architectures. So before go there, I'm just to try to share myself. My name is Demai. I'm a senior director of TiDB. I have been working in database area all my life. At the very beginning, I was entry-level developer for DB2 for mainframe, one of the legacy database. And I think the first official release was 1983. That's how old it was. And at some point, about 12 years ago, I was working for the Red Hat HBase for 2 years. If you check the JIRA, the replication, backup restore, you have my name on it.
Yeah, to share screen.
Okay,
We are live streaming.
That's everything when we go deeper on the cluster, there are always some issues.
Sorry.
Okay, now.
Okay.
Thank you. Come back. And and then I'm working for Xiaowei, and I'm working on a database called Gaosi 200. That's one additional code. It's a data warehouse. And my first trip come to Singapore was 6-7 years ago. And that's I was in charge with database international business for Alibaba Cloud. And just 2 months ago, I relocated from United States to Singapore and joined the TiDB. So very glad to be here. And the weather seems okay, better than I thought actually. Oh, okay. Every talk, there are always 3 major philosophical questions like that. First, who we are. TiDB, we founded roughly 10 years ago, and we have been growing all by ourselves, and both from a geographic perspective, but also from customer perspective. And with that, we have a database called TiDB that we are doing. You can think about that as a database that was built on top of the ideas of distributed database. Something was come out of this Spanner paper roughly 15 years ago, and is a MySQL compatible one, have full ACID compliance, and it is a H-type database, offer both OLTP transactional and OLAP analytic database. And where we're going globally. Now we have 3,000 plus customers, including some of the probably like Airbnb, LinkedIn, it's quite popular here. Databricks is one of our biggest partner together to support customers. We have our banks and also e-wallet like PayPay, one of the largest one in Japan. And certainly we have other very important customers. About 6 out of top 10 cyber currency exchange we are supporting right now. That's why I want to talk about in today's discussion. Before we go there, I just want to give a quick overview about the architecture of TiDB. And for us, scalability is everything. This picture is not today, it's 15 years ago. That was a day that Dow crashed about 1,000 points. In about 400 history of stock market, that's the fourth flash crash. The largest one in the shortest time period, triggered by computer trade. That was 15 years ago. And about 3 weeks ago, we have something similar happened 3 times a day. And the reason I remember this picture is I was working overtime with my customer. That was a stockbroker in the United States. And because the volume of that day, they cannot finish their batch job and the reporting job overnight. And I can do nothing because they was on the fixed resource system. All we can do is waiting and pray the job can be done before 9 o'clock that morning. Because 9 o'clock, what that means? Well, actually, I should say before 6 o'clock that morning because they're pre-market. 9 o'clock is official market. We can do nothing 15 years ago. Well, we were lucky we got it done before that. And we spent all night on the job. So now scalability is everything. This is the simplest architecture I'm putting here. So if I'm looking at the top corner is the PD, we call the placement driver, which is the place that you guys think about. It's a timestamp oracle. Timestamp oracle is the transactional series number that to make sure we have ACID, we have isolation level that's ready for transactional database. And certainly we also have the metadata in there that control and provide stability and scalability and also availability. The middle here is the TiDB. This is also what we call TiDB engine, which is the SQL layer. It's a stateless engine. That means it can be scaled out, scaled up. It can crash without impact the user data, without impact the user's application. It will be automatically switched over simply because it's stateless. On the right left corner is one thing called TiDB. You can think about it is like a RocksDB. It built on top of access table. It's a low level, but for high performance transactional. And there is a Raft protocol for the implement between the TiDB. So we have 3 copies and make sure if one of TiDB crash, we can quickly switch to another one as the leader of the Raft protocol. We also provide something called the TiFlash. That one is, you can imagine it's more like a Parquet-like column storage. It's automatically synchronized with the TiDB data. And because the column restore, and we have a specialized optimizer in TiDB to use that column restore. So we can provide a OLAP like performance for complex query, for joined query, and usually it will be 10 to 100 times faster than a normal MySQL. And sometimes in a special case, maybe 1,000 times faster because the column is specialized for OLAP. And it's isolated from the OLTP data. And that's very important here. Okay, certainly we are not just a database, it's a platform. You have to have something that can have the data in and have the data out, be able to provide observability, provide the data backup restore, and make sure it can be deployed easily. And since we are in the AWS room, so I'm saying we are on top of AWS public cloud. Yeah. But that's for sure. Actually, I was just in Shenzhen the past Wednesday and was in AWS summit for that. So for TiDB, we can deploy it on private cloud, on a public cloud, and also on a managed cloud offering. So that's the fundamental. Let's go to something more interesting. Actually, the reason I'm saying more interesting is I have been talking about database in my past life 20-some years. So that's kind of boring to me. Let's talk about Web3, which I'm learning right now. For Web3, it's different than Web2. Without going into any details, the most important difference is on Web3, the ownership is by the user. Not like a Web2, the platform, the host can remove your data, can remove your things as they wish. For example, YouTube, they can remove it. But Web3 is always on the chain. It cannot be removed. So among all the different things, that's the most important fundamental. And we need to talk about that in the detail there. So at least there are 3 things for blockchain, which all come from the first one, the Bitcoin. And I read that paper when the Bitcoin only cost $10 per piece. I like the paper, I didn't pay the money, and I'm still working. So at that time, the digital ledger will be able to record everything there. but because it will provide one public chain to provide for every transactions, so it can only do 4 to 6 transactions per second. Think about that for the global everyone. And the second phase, we go to the contracts. The smart contract can implement some kind of code in there, some logic in there, and they can implement more ideas in there, including like news, including the picture, NFT was with at some point. So it can have more trust, more security. However, the efficiency is still very low, roughly 10 PPIs per second. Moving forward on phase 3, there are much more programmable mechanism in there, and we began to see the exchange to the cyber currency exchange on the market since maybe 5 years ago. And now we talk about the crash again. That's the picture we just saw. And everything seems same as a stock exchange. The only difference is 100, 1,000 times more volatile than the stock market. And 95% of the exchange is triggered by computer, not by human being. And we may have 1,000 trading pair with like, for example, you trade a Bitcoin to US dollar, US dollar to, and the Singapore dollar to Bitcoin, and also different currency to another one. So that's a pair. And there are for a normal exchange in the top 10, they can have 10 million orders a day. And at the peak, if some event happen, 30,000 OPX. That translated to about times 5 or to 10 SQL statement in the system. And I will talk about another most boring thing there. So the challenge here is, as originally, they will use sharding and partition in a database because that provides the best latency and be able to scale out, which is a fair, good architecture because the exchange need the latency will be 2 to 3 milliseconds and like to much faster. Remember again, I mentioned many things happen by computer, not by human being anymore. That's why it can be that fast. But the sharding is always have a challenge because they are good at doing the transaction, but they cannot really do the history record. They cannot build the chart, the candlestick chart to do analysis. And they also very bad at data archiving. They maybe can say, for example, the sharding, one of the best sharding is build a middleware on top of MySQL. And MySQL is good, but it's not very good at storage data. And some exchange can only have 7 days of history data. They can do within 1 month, 2 months top. More than that, the whole system going slowing down. Why? Well, I'm using one of the oldest architecture to talk about, but there's something similar. Think about B tree or B plus tree in some of our school work. That's different leaf. Once you have one more leaf, there's one more IO. And that's why it cannot have a much deeper, cannot support so many data. That's a challenge there. New database need to be in the picture. And TiDB, as already shared about the architecture, can be part of the solution. One thing is many of the exchange or the cyber currency supporter using MySQL. That is a legacy behavior back to Web 1.0. 30 years ago, when people use Linux, Apache, MySQL, and PHP, not Python or PHP to build the first website. So people use MySQL. I will use MySQL on internet. And that's why MySQL is kind of natural fit into there. And because the TiDB can have the infrastructure to do the ETL, well, without you knowing it from TiKV to TiFlash. So it can satisfy both the OLTP requirement, ACID, the isolation, and also the complex query. And that's the solution here. But without go there, I like to talk about the real customer case. I'm talking about the real customer case here. Well, for the privacy, I changed a little bit, and but I'm not to expose my customer's name here. So the most popular one, the exchange, is a centralized exchange. They will have two kind of process. One called the spotting trading process. And that is really simple because for the spot trading, you do have to have a coin or have the government money there. But that is only limited. Many of the players in this field using contract trading. They have more complex. Think about if you have a stock, you probably know what is option and what is the feature and what is the margin. Basically, use leverage. And $1 you can play $50 equity there. That's called contract trading. For contract trading, besides you have to put the order in, put the order out, and to matching the order, which is the same as the spot trading, you also have to have this position and the liquidation comparison. Make sure the player or the buyer or seller have enough equity, enough real money in there. And that is another logic. And as I mentioned, for these numbers, at least 1,000+ trading pairs. But another thing is, I didn't mention last time, although I use the same word. The trading for cyber currency is 24/7. It's not 9 to 4 o'clock. And that was a good old day. When after 4 o'clock p.m., I'm talking US Eastern time, and everyone can go home because the market is closed. But now, for the cyber currency, it's 24/7. There's no downtime, no downtime window, no batch job I can do overnight, like what I have been doing for 15 years ago. So that is one important part. Another thing, recently, in the past 2 years, there is decentralized exchange. Why someone wants it? Decentralized exchange is truly as the player or the buyer or seller have their currency on the chain and it's safe and is more satisfied for their own requirement. When some of the centralized exchange for some reason could not hold in the past couple of years, you probably see the news. People began to move to decentralized exchange to have more control. However, they do have their challenge. And besides the green color here, I think it should show the benefit. There's one thing we call the high gas fee. You have to think about to do a change, maybe cost $10 or even more for the network, for the computation. And also because without a centralized place, the matchmaking is inefficient. It takes minutes. In some extreme case, take days to get a match of your order. So that's different. So people change a little bit. They make sure all the personal information, your e-wallet, your hash key is still on the public chain. However, for the exchange part, the order matching will be on the centralized place. And that also be part of many decentralized exchanges. They want to use that as an advantage. And today, the decentralized market can also meet about 100 million orders a day. So this is the real case there. So at the beginning, the customer using a sharded shared storage cluster, and both for the order and also for the archived history information. So TiDB is here. So we will still keep the shared storage cluster to the transaction. We call it the right here on the right up corner. And the TiDB will be the read-only one. So this architecture will be much simplified and satisfy the customer requirement. And the TiDB have an indexed channel, so you can automatically inject the ETL, the data, the history data from the cluster to the TiDB. And that satisfies the customer requirement. So by doing that, the customer, the exchange, can easily have their user to query up to 1 year and even longer the history record, so you can analyze that. And they can build more business on top of that. And for the saving, they can saving roughly a quarter of saving and can reach the top of 300,000 QPS. There's another system there. They was using MySQL and using binlog to replicate the MySQL binlog to Elasticsearch. And before, they can only save 7 days data in MySQL, and some of the older data will go to TiDB, and for analysis, they will go to Elasticsearch. And after this change, for their tables, they can just using MySQL and the TiDB. And oh, I apologize. I want to emphasize one thing. For this case, some of the scenarios, because the low latency and the high scalability they need and the high throughput, they also need to implement an in-memory method. Well, I'm oversimplifying that, but the solution involves something like a Redshift or their own application to have the in-memory write and make sure, but they also make sure the log will be saved and write as an appended only into TiDB to make sure nothing will lost. But the in-memory only in-memory can guarantee their throughput and latency. Okay, we talked about that. That have been running for like about 5 to 6 years already, and I'm talking about today. There's one called the impossible triangle about the blockchain. So basically, people look at the security, look at the decentralized, and also scalability. You cannot have all three of that. And for today, some of the users, or I will call the Web3 company, will emphasize, for example, Bitcoin like security and decentralized. And for some others, they are looking at the scalability there. And there are more different players in these pictures. And this market has been matured. And there are more and more sub-sectors in this whole market. And some of them are my customers, but I'm not going to name names. But I'm just looking at that. There are e-wallet. I just talked about with one of the largest banks in Indonesia. There are more latency systems, but they are talking about, okay, can I provide an e-wallet, but also have the customers, their customer saving be put on site to buy something like a Bitcoin? How we do that? So this is actually far away from what we just talked about in exchange. People began to use cyber currency as a real money right now, and gradually into this market. And there's a trend, and I have borrowed the picture online, and you can see the data have been growing very fast in the past, I would say, 4 years, 5 years. So the older solution was a traditional architecture. On the left-hand side, people using RDS, which we are using, when you try to use RDS as a term, it means something, for example, AWS RDS MySQL, and doing a sharding on AWS, something similar on that. And then if people use data warehouse, maybe like Redshift, or I was working for Huawei, the TiDB, something similar, and they have to handle the ETL on between. And with TiDB, all this complex layer can be removed using TiDB because the transactional and analytic will be put together, and the synchronization is handled within the Raft, within the Raft protocol. And this is another of my customers, and trust me, that will be my last one. This is the online blockchain insight service. So I just talked about exchange, right? That's certainly one of the fundamental of stock market. However, when stock market was getting mature, people began to use the data, like the public data I just showed on public chain, on public domain, to do analysis. And by doing analysis, people want to look at, okay, when I should buy a Bitcoin, when I should sell, or some other exchange. Also think about that can be exchange between different cyber currency, or between cyber currency to government currency. There are so many pairs and different location. For example, here we probably talk about stable dollar. And when I go to Hong Kong, I talk about Hong Kong currency, and I was in Silicon Valley 2 months ago. I'm talking about dollars. And this kind of exchange that happens. And always have high concurrency. That's the most requirement. And people want to, Web3 is a moving faster market. People want to move to the market very fast. The reason I'm talking about that, I want to stop for a second. Many of the things here, I believe, was in the technical area 12 years ago when big data was coming. When using Hadoop, I was working for HBase. To build a big data platform, you need maybe 12, a dozen or 2 dozen different components to maintain that. And when I was working for IBM, I built HBase and maintained a paper that already take me 5 person to know how to do the maintenance, to how to support my customers. So complexity may be a good thing if we have the right personnel, but also it's a very expensive one. How the speed to faster to market is another important thing for Web3 and for other moving faster areas. And that's what we as the Pinghan can provide to everyone here. We are distributed native. It's built on top of the distributed papers, and we also have the paper talk about how we do that in the details in VLDB and Sigma, those top 3 database conference. We are cloud native. We support all the popular cloud, AWS, GCP, Azure, Alibaba Cloud. And we also AI native. For today, I don't think I have the time for talk about AI, so I've stopped here because about 4 days ago, I was in Shenzhen talk about AI and also in AWS place. Okay, that is all my talk for today. I think, do I have a couple minutes for questions?
Yes.
Okay, thank you.
When you said 24 hours opening, are you referring to COMEX?
When I talk about 24/7, I'm talking about the central currency exchange is go around the globe. They are not controlled by any single government, and everyone can, at any region, any time, can log in to do an exchange. So that's what I talk about 24/7. And I compare to the traditional stock market. All the stock market have roughly 9 o'clock in the morning as open or 9:30. Sorry, I don't remember the exact time, and close at maybe 4:30 p.m. So they have a range. And usually at the night, they will say, okay, I'm closed down. No matter what happens, I'm not allow you to do any trading at night. So So that's different. But for we as a database building infrastructure, we know for traditional stock market, we have a window to upgrade to patch the bug there. But for central currency, we don't. 24/7. That's
The
it.
central base is in the US.
Well, we don't know where the change is.
I see.
That's the central currency. It can be certainly in Singapore, it can be in Hong Kong, can be in Dubai. It depends on how you build your architecture. And I know the top exchange provider, they have region around the globe.
So at 4 a.m., if I have Ripple, I want to sell off. I can do
Well, yeah, for them, where? It's always the sun somewhere.
that. I see.
Please.
Go back to the previous,
May I know which part you reference to?
the one you replaced the whole ETL.
Is this one? Yes, go ahead.
Yeah, you have already told us the advantage, right, to have the this architecture.
Mhm.
Can you also elaborate more in terms of is there any drawback or disadvantage?
Okay. So the advantage I will talk about, the drawback, well, is certainly one thing. If I can use a public number here, let's say abstractly use cloud spanner. Cloud spanner will build on top of the true timer in the hardware. The true timer have 7 milliseconds as top arrow. So for that transaction, when I learned that maybe 3 years ago, that true timer means your transactions latency at best is 14 milliseconds. Think about that. And we are not using that true timer. We are something like if you are come from US, there's a other company called TiDB, use a hybrid timestamp oracle there, and it takes longer. Now back to your question. For this architecture, it will be very difficult, not impossible, but very difficult to achieve 2 to 3 milliseconds for the latency. Especially if you want to do one transaction with much more complex orders. Something in memory has to happen in this architecture. But I want to emphasize that on the left-hand side, yeah, left hand, is that right? Sorry, is this right? This like, okay. Okay. It also needs in memory, some in memory computation there. Although if you run one cycle, it can achieve 2 to 5 milliseconds. It will be the best you can get, but it cannot be consistently provide that performance. In many cases, in memory is the only solution. So the drawback is for the old architecture, you maybe use MySQL and try it to satisfy 2 to 3 milliseconds, but use TiDB, some in memory coordinating has to happen. But the log will be running in TiDB and the data will be there, will not be lost.
Okay.
Okay, thank you. Appreciate it.
Let's bring up the next slides. Okay, thank you, Demai from TiDB, and we are just about on time, and thanks so much for the previous 2 speakers. And the third one is the founder and CEO from Tacnode, Xiaowei. Welcome, Xiaowei.
Thanks, Roger. Good evening, everyone. Welcome to today's talk. I'm Xiaowei, CEO at Tacnode. In Web3, timing is everything. Whether you are reacting to token jobs, tracking wallet flows, or spotting momentum before the crowd. The age goes to whoever the person sees it and acts on it first. But this is problematic because the data infrastructure that we rely on are not built for this. By the time your dashboard updates, the opportunity has already gone. By the time your AI model runs, the market has moved. In the last couple of years, we have been building a new real-time data engine from the ground up, designed to exactly for this kind of environment. It provides sub-second insights at large scale across fresh multimodal data, including from blockchain events and price feeds to campaign telemetry or wallet behaviors. In today's talk, I'm going to walk you through where the traditional data architecture falls short and how we build Tacnode to power real-time AI at large scale for crypto. Over time, organizations have struggled with data sprawl, where different applications, transactional applications, data applications, AI applications, all rely on different specialized databases, leading to fragmented data infrastructure, data silos, and operational overhead. So they try to address this problem by introducing data lakes as a cost-effective data storage, and also data warehouses for structured queries and BI reporting. The data lakehouse is introduced to bridge the gap between these two different systems, combining the flexibility and scalability of data lake with the performance and the governance of data warehouses. With the data lakehouse, organizations can consolidate their BI and AI workload in a single system. They can store data in open format while still being queryable using SQL. Organizations can power analytic dashboards and do AI model training and run large-scale batch analytics on large-scale data processing without needing specialized systems. For AI applications, this means having a single repository where AI teams can store raw data, engineer features, train models, and run batch predictions, while still making the data available for SQL queries. This is supposed to reduce the complexity as it eliminates the need to move data from between storage and different process systems. It works well for batch usage, but when it comes to real-time AI inference, it falls short. In the next slide, I'm going to show you where it breaks down. In a data lakehouse, the lakehouse itself serves as the offline feature store. It stores processed features that are transformed from raw data. They are used for model training, but the data lakehouse is not capable of providing the instant access required for real-time AI inference. To solve that problem, people have to introduce an online feature store. The online feature store is specifically designed to provide the low latency access to features on demand, which is critical for time-sensitive applications such as fraud detection, personalized recommendation, and dynamic pricing. Having separate feature stores for online features and offline features create challenges in data synchronization, as the features in the online store have to be exported from features in the offline store. And the offline store is using batch-oriented processing, which introduces data lags and data delays. To work around this data delay, engineers often bypass the data lakehouse to use a external stream processing system such as Apache Flink to directly process and feed real-time features to the online feature store. Such a fragmented architecture creates more problems than it solves. AI models need fresh data to make accurate predictions, but Lakehouse process features from raw data using data pipelines, and each stage of the pipeline is the batch transformation. So even if raw data is ingested into the system very quickly, it still need to go through multiple batch transformations. Each transformation adds delay to the data. At the end of the transformations, the features have to be exported to the online feature store. So when the online feature store receives the data may already be outdated. As a result, the AI model is making predictions based on stale data. For lots of AI model, it depends on lots of various different types of data in different forms: structured data, semi-structured data, unstructured data, and vector data to make predictions. But unfortunately, most of the online feature stores out there cannot handle all these different types of data. As a result, developers have to introduce multiple instead of one online feature store to handle them. For example, they may likely to use a relational database to store structured data, a NoSQL database for semi-structured data, a search engine for full text, and a vector database for vector embeddings. This fragmentation not only makes online retrieval queries slow, but it may even degrade the accuracy of retrieval results and causing the predictions to have lower quality. Managing the complex ETL pipelines for batch processing in a data lakehouse is a major challenge. But on top of that, when we add complex streaming pipelines, it just multiplies the complexity, making it practically impossible to provide a reliable and consistent view to decision-making. Managing data lakehouses and multiple online feature stores, a stream processing system is a major challenge and reduces productivity. So as teams are forced to spend their time working on infrastructure instead of building and improving their AI models. This will slow down innovations as the resources are spent in undifferentiated work. So what does an ideal real-time AI workflow looks like? In an ideal system, it should store all the data, raw data, offline features, and online features, all in one system, completely eliminates the need for disconnected systems and the operational overhead associated in managing these systems. Raw data gets ingested from various data sources, business applications, a relational database, and Kafka at real time. Once the data is ingested, they get transformed into offline features and online features. The offline features undergo batch processing, and they are used for historical analysis and model training. On the other hand, the online features have to go through incremental transformation to make sure they always stay up to date. Machine learning engineers and data scientists need an efficient way to access this massive amount of data. They want to analyze the data interactively at real time. They want to explore patterns in the data. They want to experiment with transformations on the data to come up with better features. This all has to be done interactively without waiting for daily batch pipelines. When an inference request comes in, a retrieval request is sent to the system. The system should be able to effectively retrieve all kinds of data related to this request, including structured, semi-structured, unstructured, and vector data, and be able to present all the relevant and most accurate result to the AI model. The AI model makes a decision based on such input, and the decision is applied by the business application. A/B test is used to measure the business impact of this model. And the machine learning scientist uses such feedback to modify the model to make it better. This whole process is very iterative. In fact, the process itself is best described as iterate. I for ingest, raw data gets ingested into the system at real time. T for transform. Once raw data is ingested, they are transformed to online features with online features. E for explore. Data scientists and machine learning engineers can explore the features at real time. R for retrieve. The online features are retrieved at real time by the inference service. A for act. The decisions are acted on immediately to drive business impact. T for test. The model is tested for its business impact. E for evolve. This, machine learning engineers continuously evolve the model when new data comes in to make sure the model stays relevant. Unfortunately, there is no single system that can support this whole iterate workflow. So developers have to combine multiple systems to approximate this workflow. So the natural question is, how do we build such a system? That's what is Tacnode for. Tacnode is a real-time data engine that is used for decision-making at large scale. Tacnode is PostgreSQL compatible. From the outside, when you interact with Tacnode, you get exactly the same experience when you are interacting with PostgreSQL. But from inside, Tacnode is developed from ground up, a completely new system. Tacnode is horizontally scalable. You can add more machines to get better performance. You will never run out of performance with Tacnode. Tacnode is not only performant for transactional workloads like PostgreSQL, but it's also optimized for real-time analytics and AI workloads. Tacnode eliminates the trade-off between PostgreSQL simplicity, scalability, and performance. In the next few slides, I'm going to talk about each one of these and explain how Tacnode makes them possible. Tacnode integrates seamlessly with PostgreSQL ecosystem. Whether you are using pgadmin, dbeaver, Navicat, or DataGrip for database management, or Hibernate, MyVadis, SQL Alchemy, or Gong as your OIM framework, Tacnode fits right into your system without any change. On the analytics and BI side, Tacnode integrates with Tableau, Click, Power BI, and Looker. And for it also works with Airbyte and Filechain for data integration and DBT for data transformation. Even PostgreSQL's documentation remains valid, making the transition a smooth experience. By integrating seamlessly with PostgreSQL ecosystem, it allows our users to benefit from PostgreSQL's ecosystem without learning new technology. Tacnode also inherits the abilities of PostgreSQL engine. Tacnode supports multimodal data, structured, semi-structured, unstructured, and vector data, which is critical for modern AI applications that rely on diverse data types. Tacnode inherits the advanced query capabilities of PostgreSQL, including complex joins, aggregations, window functions, making it ideal for feature transformations and deep data exploration. Tacnode supports advanced index in Postgres, which is critical to provide high throughput retrieval queries for real-time AI inference. Tacnode supports strong consistency by supporting full ACID property, providing consistent and reliable data to AI-driven decision-making. So PostgreSQL offers a strong foundation, but real-time AI pushes far over its limit. Tacnode extends PostgreSQL's capability by adding horizontal scalability, real-time data transformation, and performant analytics. In the next slide, I'm going to talk about how Tacnode overcomes PostgreSQL's single node limitation. Tacnode introduces the concept of node groups. Each node group is a virtual PostgreSQL cluster spanning multiple nodes. Unlike PostgreSQL, which relies on single primary node for all writes, Tacnode supports distributed transactions, which enables horizontal scaling across multiple nodes. It enables higher data ingestion, as well as high throughput retrieval queries without hitting single node bottlenecks. Tacnode decouples compute from storage. The data is stored in database, which can persist independent of the compute resource out there. Compute resource can be modified by adding or removing nodes into a node group without affecting the storage layer. On the other hand, the storage grows transparently without impacting the compute layer. Multiple node groups can exist in parallel. So each one optimized for transactional retrieval or analytic workloads. Tacnode is built on top of Kubernetes and cloud storage, which makes it straightforward to deploy on AWS and other public cloud platform. The cloud native design enables cloud agnostic scalability, which allows businesses to grow without worrying about hitting infrastructure bottlenecks. With its distributed architecture and separation of compute and storage, cloud native flexibility, Tacnode overcome PostgreSQL's single node limitation. In the next slide, I'm going to talk about how Tacnode optimizes for real-time BI workloads. Tacnode supports row-based storage for transactional workloads, columnar storage for analytic workloads, and hybrid storage for mixed use cases. Row-based storage is optimal for fast lookups, and columnar storage accelerates your analytic queries with very efficient aggregation and filtering. And the hybrid storage allows both transactional and analytic queries to be running on the same data without duplication or moving to a different systems. By providing such flexibility, Tacnode allows our users to choose the right storage for his workload. Unlike PostgreSQL, which executes query on a single node, Tacnode distributes query execution among multiple nodes, leveraging vectorized execution for maximal efficiency. This massively parallel execution dramatically reduces the query execution latency. So for BI users, he sees much shorter query execution time and more efficient resource usage while querying billions of records. Tacnode integrates with Iceberg natively. BI users can query data stored in data lake directly using SQL. This eliminates the need for data pipelines which move data from the data lakes to the data warehouse. By providing a unified access to data stored in the data lake and data warehouse, Tacnode bridges the gap between these two ecosystems, making it easier to derive insights from different data sources. With its flexible storage, distributed and vectorized query execution and native integration with data lakes, Tacnode positions itself as a high-performance analytics solution for fresh data without the overhead of traditional data warehouses. On the AI side, as we talked earlier, a real-time AI workflow is inherently iterative. Data has to be ingested, transformed, explored, retrieved, and are used to act on, test, and evolve AI models. Tacnode supports the full iterate workflow in a single system without the need for manage multiple systems. Tacnode enables real-time data ingestion, data gets updated when transactions occur. This is very different from a lot of other systems that use append-only ingestion. Tacnode supports upserts, partial updates, deletes. Updates are immediately visible without waiting for batch processing. By keeping raw data always up to date, Tacnode enables continuously updated data for downstream feature engineering without any delay. Tacnode supports incremental feature transformations with Tacnode supports real-time feature transformations with incremental materialized views, only updating the affected records when upstream data changes. Unlike Flink SQL, which needs the external streaming engine, Tacnode natively integrates the ability to do incremental update. By eliminating an external stream processing system and the overhead of managing Flink SQL jobs, Tacnode provides a much simpler and resource-effective solution. It enables real-time freshness while reducing the operational overhead, eliminating complex state management, avoiding unnecessary manual tuning. AI models in Tacnode always work on fresh data, while significantly simplifying the architecture compared to stream processing data pipelines. Any AI data platform needs strong BI capabilities. Tacnode provides efficient BI capabilities using the optimizations we just mentioned in the previous slide. With Tacnode, machine learning engineers and data scientists can explore patterns in your data, in massive amounts of data, and experiment with transformations, improve his features iteratively at real time without waiting for complex batch processing pipelines. And Tacnode supports low latency multimodal retrieval with OmniSearch, integrating indexing and query execution across structured, semi-structured, unstructured, and vector data in a single engine. For semi-structured data, Tacnode supports JSON parse query and also leverages the Jiang index for fast retrieval without scanning the whole document. For text search, Tacnode also leverages Jiang index for fast retrieval, and for vector search, Tacnode supports both IVF flat and HNSW index for efficient, approximate, nearest neighbor vector search. By integrating all these different retrieval methods in a single engine, Tacnode was able to completely eliminate external online feature stores and cross-system joins, and be able to provide the accurate retrieval result with minimal latency. Tacnode provides a real-time AI data platform by unifying OLTP, OLAP, online feature store, stream process systems, stream processing in a single system, enabling seamless real-time AI workflow. With Tacnode, all AI models work on real-time data. Tacnode can turn your data into decisions in milliseconds. Now let's take a look at how Tacnode works in action. In Web3, information is not just valuable, it's perishable. So when a token moves, when a campaign launches, when whales quietly start accumulating, the difference between acting now versus finding out later can mean everything. So dashboards like this are not just used to show prices. They are used to understand the behaviors in the wallet, to understand campaign momentum and market psychology. Let's take JUP airdrop, for example. When it went live, wallets lit up. Sniper bots raced to front-run the markets. Whales move in with 6-digit buys. KOLs and early backers quietly position themselves. This looks very chaotic from outside, but for users of this dashboard, it means something else. It's an opportunity to investigate live. A user clicks on Smart 68, which is a curated list of wallets which have a proven track record of making well-timed bets. Instantly, the feed filters down to only show their recent activities. Your user adds more filters, only show buy orders in the last 15 seconds with minimal size of $5,000. Now, it's no longer just a stream of transactions. It's a signal. Who is buying, how much, and whether he believes the momentum is building. The user can also be from a campaign team. So he switched to KOL VC 451 tag. Within seconds, he can answer questions that used to take minutes or even hours to answer. Who are participating? Are they putting real size? Is the campaign landing or falling flat? It's modern reporting. It's they are not waiting for reports. They are watching the outcome unfold live. All this happens in sub-seconds. The filters are dynamic, stackable, and immediate. So users can combine wallet tag, trade type, time window, the size of the trade, and the trade origin to understand what is happening. This is without any hesitation or guesswork. This is modern reporting. It's live forensics. But so this is the power of this dashboard. It's not just showing the market. It's letting users interrogate it. In moments like JUP, L-job, where every millisecond matters, this is more than just helpful. It's game-changing. But providing such experience, the ability to slice live token transactions is surprisingly difficult to do. Our current data infrastructures are not designed to do that. There are 3 major challenges. The first challenge is the freshness. Users expect to see a trade as they happen, but most systems out there will buffer incoming data or rely on batch processing. So when the data shows up in your dashboard, the moment has already passed. The second challenge is the concurrency. The system is not processing one request at a time. Thousands of users, bots, and internal tools are hammering the system continuously at the same time with different query patterns. Most systems are just simply not designed to handle dynamic queries at such a large scale. The third one is flexibility. Users want to filter the transactions using wallet tag, trade type, time window, size of trade, and origin, often in combinations that you didn't expect. This creates exponentially number of different query patterns. There is no way you can create an index for each one of them. And when most systems fall apart when you ask for both flexibility and speed. Each one of these problems are difficult by themselves, but when they combine together, it basically ruled out all the systems out there. The thing is, each one of such problems has been solved before, but just not solved all at once. For example, if the only thing you care about is freshness, traditional database might be good. It offers fast writes and immediate visibility. But the moment you start running a filtered query with a predicate which is not indexed, the performance just collapses. On the other hand, if all you are interested in is multi-dimensional filter, search engine might sound like a natural fit because inverted index can allow you to slice across multiple dimensions. But a search engine will need to fan out queries across multiple shards, which makes it very difficult to scale up to 10,000 queries per second. In addition, search engines rely on refresh cycles to make data visible. So the data you see in a search engine may not always be up to date. On the other hand, data lakehouses offer a scalable and cost-effective analytics, but they are designed for batch, not interactive experience. So ingested data maybe not visible for minutes or even longer. Furthermore, the Lakehouse are designed for execute a small number of large analytic queries instead of a large number of small, fast queries. The concurrency simply is not there. So developers are forced to stitch multiple solutions together. They introduced a streaming engine for real-time data ingestion, a search engine for multi-dimensional filter, a data lakehouse for analytics and the cache layer to speed things up. This sounds like it should work on paper, but there is one important invariant. The data delay, when you combine two systems, the data delay is the irreducible quality, meaning when you combine two systems, their data delay are not going to cancel each other. Instead, they may need to add on each other. So when you combine multiple systems together, you can never reduce the data delay. So even though the dashboard may look very fast, but it's fast on stale data, the moment has already passed. You can never combine multiple systems to reduce the data delay. With Tacnode, Tacnode eliminates such trade-offs. Tacnode was not built as the real-time layer on top of batch processing. It's not repurposing a search engine for analytics. It's built from ground up for such use cases. In Tacnode, freshness is native. As soon as data is committed in Tacnode, it's immediately queryable. So there is no refresh cycle, no index lag, no handoff between systems. This may sound obvious, but in practice, in lots of systems, they will introduce delay just to keep up with the ingestion and the indexing. In Tacnode, there is no gap between write and read. You are always querying live state of the world as things are happening. In Tacnode, the high concurrency is built in. Tacnode combines global secondary index with distributed query execution for horizontal scaling, even beyond millions of queries per second. In real life workload, there are repeated patterns. Tacnode can optimize for such patterns by creating global secondary index without sacrificing the flexibility and performance of long tail queries. With Tacnode, the flexibility is first class. With its columnar storage, Tacnode only need to access the columns that are used by a query. So unused, uncommon, and ad hoc queries also runs fast in Tacnode. This is very critical for exploratory queries, where flexibility is far more important than pre-optimization. Users are free to mix and match different dimensions without worrying about explosion of index count and slowing down data ingestion. So with Tacnode, with Tacnode, it was able to solve all these problems at once, and it's designed for driving decisions at scale for such fast-moving data. Let me take you to a different use case here. In this case, a user logs into a retailer's website. she started browsing casually, looking for a few essentials. Then she added crepe to her shopping cart. Also added a bottle of prenatal vitamin. This is not random, it's a signal. Something just happened in her life. Real-time AI begins with such a signal. The moment she clicks on Add to Cart, Tacnode goes to work. The event gets ingested by Tacnode, and it gets transformed into a feature. She's likely a new parent, high-value signal, and her buying pattern likely will change. All this is happening at real time without batch processing pipelines. In the same session, recommendation engine kicks in. It retrieves the fresh features that we just updated and shows her baby-related products before she searched for, but now she clearly needs. In the backend, the growth analyst submits a query to understand the conversion of the conversion rate. They are not working on a static snapshot of data. Instead, they are working on the most recent data that powers the recommendation engine with all the features that just happened. They make tweaks to the targeting. They compare conversion rate among different cohorts, iterate the model, make changes to the model. And meanwhile, they are also running A/B tests with a new recommendation model against the baseline, collecting live metrics to evaluate how the model is doing. This is iterate in action, all in a single system on fresh data. Even though this is an example in retail, but the pattern should sound familiar to you. It's not retail-only logic. In Web3, such signals happen all the time. A token gets swapped, a wallet signs a contract, a user mints, stakes, or exits a pool. Each one of these is a signal, which is an opportunity for you to act. Tacnode allows you to take actions while others are waiting for data. When data is late, when data is not fresh, your decision is already outdated. Here is a quick summary of the key strengths of Tacnode. Tacnode is PostgreSQL compatible. Tacnode is cloud native and cloud agnostic. Tacnode support sub-second insights at scale. Tacnode can turn your data into decisions within milliseconds. There's a kind of performance that you can buy. Simply add more machines to your current data stack. But for the kind that you cannot, for example, like true data freshness, you need a new data engine. That's what Tacnode is built for. Real-time decisions, money cannot buy. Thank you.
A little bit over time, but one or two questions, if there are any. Yeah, go ahead.
Just now you mentioned that Tacnode, isn't it? That the data lasts very short, is it? For a short while.
What do you mean?
Was it Tacnode? Or?
Tacnode, Tacnode.
Yeah.
Yeah.
The data lasts very short while, is it? I mean, is it less than 15 seconds? Is it?
So that's just the example. In that example, he wants to show the trades that happened within the last 15 seconds because these trades are the most important one.
So this could be ideally for unidentified gambling and unidentified lotteries.
So basically, whenever you want your data to decision within very short amount of time, when this lag makes a difference, if 1 second and 1 minute makes a difference to you, that's where Tacnode steps in.
Thank you.
You're welcome.
Hey, thank you, Xiaowei. All right, thank you so much for everybody. So we have the last one from AWS, Mr. Gong. So where's he? Albert, can you help me ask him? You know how to bring up the slides? Okay, there you are. Okay. Okay, it's your turn now. So let's welcome Paul.
Yes. My name is Gong Wei. You can call me Liu. I'm from based in Singapore. I'm previously working across different companies like Google, Amazon, Asia, Microsoft, and previous 10 years ago working as a system architecture in Cisco. Yeah. So actually I'm working for cloud computing for like 11 years. Yeah. So. And previously I based in Shanghai. So last year I relocated from Shanghai to Singapore because I'm taking care of the Amazon Web3 team. So this is I'm very excited because Web3 has a lot of innovations recently, and in the past 5 years we see a lot of booming. And Amazon has a lot of native customers, and including many of you here. So, so today I just want to give you some very brief introduction of what we are doing. So we have a large team in Singapore office. We have around I think like 50 sales, technical, and 10 manager here, and also we have another 30 to 40 people in Hong Kong. So we are taking most of the business for our central exchange customer. And also for our Web3 startups. We also have a startup company in here, and also we have a lot of startup team taking care of a lot of Web3 customers for blockchains, DeFi, GameFi, and also for example, like some of the recent very hot ecosystem in Tom, in Solana, in Tron. So that's our customer. So today I will give you some, I think you have heard a lot of technical details of how we enable our technical solutions set on the cloud. And I think AWS is not familiar, I think you have a lot of knowledge on that. And what we do for blockchain, what we do for Web3, because my team taking care of a lot of largest customers. Including some of the well-known like top 20 central exchange customer in the world. So we have taken care of not like 70%. I think over like 50% of the top central exchange customer are within our team. So we have managed a lot of the solution architects, and also for business developments for those customers. We're hosting most scalable system in AWS region. For example, in Tokyo, in Hong Kong, in Singapore, in US, East and West. So I think most of you are familiar with those building blocks. We have treated us as a builder spirits for Web3, and Amazon has been keeping very updated solutions in this tech stack for Web3. We have a lot of channel solutions. We have some of the end-to-end solutions for our developers and builders on the Web3. So, so from those perspectives, I think lots of customers taking care of the, for example, scalable, how to build a scalable and reliable system on top of the cloud. And another good topic recently is security, because recently has a lot of the security breach in the wallet system, in their trading system. So we have helped a lot of customers to try to leverage our solution, cloud native solutions, and also our third-party solutions. Build have a trusted wallet on top of the cloud. And also we have leveraged a lot of partners, and including our data partners and security partners here in Singapore and Asia. So that's why we have embraced a lot of partner solutions on that as well. And another one is Amazon has provided a lot of scalable network across different regions. We have most of the regions coverage, and also we have more regions to coming up. And also we have a lot of, recently a lot of customers are taking care of compliance and security issue, trying to open more front-end websites across different countries. For example, in Europe, in US, in Southeast Asia, in Turkey, in South America. So those are they trying to leverage our global networking and how we can speed up those transactions across different central exchange and across the on-chain and off-chain business. And another one is related to today's topic. I think you have covered a lot of details on the data solution, and it also has provided a lot of cloud-native data solutions on top of that. For example, we have most popular customers are using our largest system built on the Aurora for the transaction, and also we have distributed database. So in the last year, we have in the last event, we published the latest announcement for the DCQ. This is one of the ever Amazon has published the distributed RDS for our global customer. So previously we have a lot of built up like global data, for example, like global data table, and also some of the global database. But the DCQ is one of the first Amazon has published last year for DCQ to for the right now it's I think it's still under limited preview, but in the later half of this year you will have the public access to the DCQ. It will be first available in the US, and some of the customer are trying for that, and you can compare this DCQ as Google Spanner or some of the features like TiDB and Tacnode. So this is some of the time that we are still doing some innovations. But on top of that, I think we still have a long way to go because Web3 is growing very fast. And we are trying to, for example, on the core system, we are trying to push more of the new innovations on our EC2. For example, we are using a lot of Graviton built on that. We have the new release for Graviton 4, and we have previously we have using a couple of the, for example, a nitrogen system to enhance our EC2 security. So for on top of that, we're using Nitro Enclave to enhance like 80% of our Web3 customers for their wallet, for their risk control, and for their security. So right now you can see most of the central exchange customer and DeFi customers are using Nitro Enclave on the EC2 to build up and using that to secure their key, secret key, and trying to keep their data privacy on the Nitro Enclave. So this is, I think Nitro Enclave is one of the most popular solution and very unique to the EC2 in the AWS. And another thing I want to highlight is we on our foundation services. Recently, we are using, everyone is talking about GenAI for the large language model. And also Amazon has built up for example, the Bedrock. It's called the foundations for our large language model. We have a lot of the GenAI models. The first party, like our build up on the Nova. And also we have using third-party solutions like Cloud. And also we have leveraged other open source, for example, from Llama. And from recently very hot topics from DeepSeek. So our customers are trying to build up based on the Amazon Bedrock, SageMaker, or host on the self-build on the EC2 for their large language model innovation. So right now I can share some of the case how we can using the large language model to enable our Web3 business. There are two kind of public topics. It's Web3 for GenAI. Another one is GenAI for Web3. So Web3 for GenAI is we can use the Web3 distributed labeling for the AI security. So this is very important right now. Another is GenAI for Web3 is because we use a lot of customers using GenAI to build up like customer services, chatbots, translation, segmental analysis. We're using segmental analysis trying to capture the market signals and using these signals to input into their decision-making system, build up on a large language model or traditional language model. And using this rule-based solution, they try to give the investor the most accurate decision to buy or to try to sell. So they have this is I think one of the most hot topic right now for the algo trading using large language model. So we have a lot of use case right now for our customers, for the quant trading, for the low latency trading, for all those market makers trying to access to the, for example, to the crypto market. So this is some of the findings, and I just want to give you a very quick go through for how we can build up, for example, the node services on the AWS. I think some of you heard about the decentralized for the Web3, and Amazon has provided a most broadest portfolio of the EC2 options for you to host, for example, different nodes on the Web3. We have using, for example, some EC2 for the most high performance for host the Solana nodes, like RPC nodes or the full validators on top of the Solana chain. And also we're using these nodes provides to access to most of the Web3 developers, and you can access to those nodes. And besides that, Amazon has data sets for some of the main nodes. And also we have, for example, and also we also have the Amazon management blockchain. They can right now to access some of the major blockchains on top of the some well-known chain ecosystem. And so this is related to EC2, what I mentioned, Nitro Enclave for the security, and also we have some of the use case for the layer 2 and layer 3, and we're using the staking nodes as on top of the blockchain and host on the AWS. And another thing I want to highlight is Nitro Enclave. So Nitro Enclave is very, I think the one of the first Amazon has proposed, and a lot of customers, a lot of the cloud providers provides this similar solution. For example, Google, Azure, they have similar solution. But in my opinion, I have stayed across these three companies, but I think the Nitro Enclave in AWS is most mature, most reliable, and has most of the features. Because Amazon has the first one to using hard code and Nitro cards built on the Nitro cards. This Nitro cards has a long history. Because in 2013, they acquired a company from one of the Israel company, is a startup shipping company. They're using those chips to build up Nitro cards. Right now, the Nitro cards has a lot of features. So Nitro Enclave is one of the most important feature built up on the Nitro cards. So they all use the hardware accelerated chips to do the encryption, decryption, and how to do the computational computing. So that's the reason that they can achieve the most cost efficiency, because the Nitro Enclave itself is free. They were bounded to the EC2, so you don't have to pay any of the market for Nitro Enclave itself. You are just to consume the EC2. That's it. So this is why the most developers and also the wallet users love it. So they're using Nitro Enclave to do, for example, wallet services. Right now, most of the customer are taking care of one of the most important customer has been accepted right now, right? The greatest loss in recently, like 2 months ago, they have achieved much of the importance how they can enable the Nitro Enclave on their self-built wallet solution. So this is one things that we can give you more discussion if you have time. Yeah, so that's the second part. And third part is they can scaling the blockchain application by the service infrastructure. This has been related to most of the DApp and the DeFi. And also, besides our central exchange customer, we have a lot of startups surrounding this area. And this area, they have developed a lot of the, for example, on-chain applications. For example, DApp. For example, for the DeFi, and recently there are a lot of on the booming of the GenAI, and also they have last year they have the airdrop for lots of the meme coin platforms. They're doing a lot of the, we see some of the customers are doing a lot of on-chain analysis on the meme coin platform, and so this is some of the important trending right now in the Web3. So recently, if you want to see the Hong Kong Web3 Festival. And in the next week, you will see most of the demos on the token 2049 in Dubai. So they will see a lot of trending here for how we can booming. So behind, we're using a blockchain application built up of our AWS infrastructure using service. So we use the services mostly elasticity and reliable. And behind, because a lot of data reside in AWS, so that's why they can get most easy access to the AWS ecosystem. Because the AWS ecosystem is one of the most powerful right now. Because a lot of I think 80% of the central exchange customers are in AWS. So they were attracting a lot of startups, market makers, traditional quant trading companies, tracking to close to the AWS cloud. So that's one of the power of the ecosystem built up by the AWS. So, and the last thing I want to highlight is just I want to mention, because we have a hot trending for GenAI. Amazon has provided a 3-layer stack for the AI for the company, for most of the webs, even for the Web3. So Web3, has been, I think, a lot of the cloud native approach to the AI stack, because you can have if you want to achieve most of flexibility and data encryption, privacy, you can using a self-built on the SageMaker, and also you can using our self-made chip built up in training and inferential. And this is much cheaper or much cost efficient than the NVIDIA GPU. And also we have the Bedrock. This can provide the model access for the most of the popular models built up on Amazon. And on top, we have the Q business. This is a kind of a SaaS solution for the GenAI stack. And we have a lot of discussion for the data innovations. And Q business can regular with harness with different data solutions. On top of that, for example, they can build up the knowledge base on top of your, for example, on your business. And they can use Q for the developer for you to do the co-pilot for your, for example, for your developers. And look, also, for example, right now we have a lot of Web3 customers. They're using the Q business for their insights into, for example, for explanation for market transaction, market signals, and using the signals to do the algorithm trading, and using Q developer to co-pilot with their internal IT staff, and using the Q developers to do the innovations. So this is some of the observations from those those 3 layers. Okay, so the last page, I just want to highlight how we can help you. You can see this is my T-shirt. I actually, when I was joined, it was 3 years ago. I was running a startup previously for a technical company, and then I go to Amazon, go to Google, go to Amazon, and I find I think startup can help a lot of you, like personal and like you or the developer too, because Amazon has I think the largest and most of the scalable team for the startup across the world, in China, in Singapore, in the US, and in Europe. So Web3 has a very booming because when I was joining, I was seeing a lot of companies doing a Web3 layer 2, for example. 2 years ago, a lot of companies are doing layer 2 innovation. Nowadays, layer 2 is not as popular as before, but still we have to see a lot of innovations for Web3 plus GenAI. So that's why we can help you, for example, like building from scratch. We can give you access to the training, and also we have the startup ecosystem can give you activation for the credits if you want to do a free try for that. So this is what we can help you. And behind that, we have served a lot of the customer from 0 to 1 to 1 to 0 to 100. Those are big logos. For example, I think our team has covered a lot of the companies here. I don't want to mention most of the big logo because for the customer confidential. But I think those are well-known customers, and still this is not the whole picture. We have if you want to see from the market cap, from some of the like training reports from the token inside, you will see a lot of customers. Actually behind is enabled by the AWS infrastructure. Okay. Right. So I just want to stop here, and I welcome again for everyone to be here And last for the 12 hours work in here and a very busy Monday. I think it's a very good time to share with some of the insights from the team and also from our startup and from our partners. So thank you, everyone.
Any questions?
Any questions? Yeah.
Can you show your contacts again, please?
Contact. Yeah, sure.
Your contact. You have only contact.
Oh, contact. Okay. Yeah, that's my email. If you need, yeah. Any technical question or any questions regarding? Okay.
Just curious about your customers. Due to the confidentiality, you don't want to release, but they will be open to how they can showcase that they are using AWS. What's the reason behind that?
Yeah, because there's a lot of reasons. Sometimes it's because of the security compliance. Companies they still need to get a certification, for example, compliance check between different countries. For example, in the US, you have to be eligible to run a business in the US continental, and in Europe you have in Europe you have a meetup. Certification for compliance check for those companies. Once you get those certification, you will get authority to run in those countries. So
because that they're doing POC kind of stuff and exploring your platform, is it?
Yeah. Okay.
Do you have any representation in Indonesia?
Yeah, we have regions in Indonesia, and also we have a lot of Web3 customers in Indonesia. Yeah.
Whereabouts?
In Jakarta.
Jakarta.
Yeah. We have the Jakarta region. That's in that area. All right.
Okay.
Any
Thanks,
other
everyone. Thanks, everyone. Have a good
Thank you.
night. 你们是见过吗？第一次见。你好，AutoMQ啊，你去把那个 streaming 停一下。OK 啊，对，你看 streaming。来，不要急啊。